Number one, the purpose of these questions is to help a company decide whether or not they should use a new technique to make a component. A factory produces components for a tractor. They have designed a new technique to produce one of their components that they hope will increase its useful lifespan. They test 120 components made with the new technique and 240 with the technique they currently use. At the end of 250 hours of use, they check the components and record whether they have no cracks, minor cracks, or major cracks. The data from the trial are given in the table. This is the data. In total, 140 components had no cracks, no cracks, 141, show that the value of A is 53. So we are going to show that the value of A is 53. Find the value of B. After that, we are going to find the value of B. Okay. So I'm going to use this A and this number. A plus 88 equal 141 according to this information. A. So A plus 88 equal 141. So A equal 141 minus 88, and it is 53. So it is 53. Here's part one. Part two. According to the information that the total number of components tested for the new technique was 120. So it means if you look the table, I'm going to show you the table. Okay, new technique A plus 54 is plus B, okay, equal 120 according to this information. The new technique is 120 components. So it means A plus 54 plus B equal 120. A is 53, so 53 plus 54 plus B, 120. B equal 120 minus 107, because 53 plus 54 equal 107, and it is 13. So A equal 53 and B equal 13. Next question. Oh, this one. Part B. One of the components from the trial is selected at random. Given that this component had minor cracks, find the probability that it was produced by the new technique. Okay. B. The sample space. We'll begin with the sample space. Equal 54 plus 96. Okay. That is a sample space. According to this question, part B, okay, minor cracks 54 and 96. So it is 150. Yeah. This is the total number of components with minor crack. So we are going to find the probability first. probability if A, I'm going to use it A and B. A and B. So uh, A is represent the event that a component was produced by the new technique. So A, the new technique. B represent the event that a component has minor cracks. This is minor cracks. So the probability B is 150 over 360, and probability A intersection D is 54 360. Okay, that's the probability. Because we are going to find probability A given B. Okay, this is the probability A intersection, probability B. 54 over 360 over this is 150 over 360. 360 because the population is 360. And this is 54 over 150. Simplify becomes 9 over 25, 0.36, or in percentage, 36%. A T-square test for independence is performed at the alpha 5% significance level. Okay, 5% significance level to determine whether a component having no cracks, minor cracks, or major cracks is independent of the production technique used. State the null and the alternative hypothesis. Find the p-value. State the conclusions of the test in context, justifying your answer. Hypothesis first. Okay, so the null hypothesis is the development of cracks and technique used are independent. And the alternative hypothesis is the development of cracks and technique used are not independent. Second, we're going to organize the data into a into the contingency table. The contingency table, I'm going to create my contingency table. Right. Type. Okay. After that, new technique. Yeah. And then current technique. and total, like you may fix your table if you will create your table. But listen, this is yeah, no crack. Minor crack, major crack, and the total. No crack 53. Then this is 88, 141, 54, 96. The total is 150. 13 is 56, and the total is 69. Okay, this column total is 120. This column total 240, and the total is 360. This the population. And we're going to calculate the expected frequency. The expected frequency and with the formula formula of expected frequency is Eij equal the row total multiply the column total over the grand total, over the population or grand total. So I will begin with no cracks, no cracks, no cracks, and new technique. Okay, no cracks and new technique. It's no cracks and new technique. Okay, this 50. This is 53. Okay, this one. So it means no cracks is the total 100, 100 not 53. Sorry, 141. The total, the row total, and the new technique column total 120. Yeah. Again, no crack total is 140, 41, and new technique total 120. That's one E11. Okay. Uh, row 1 and column 1. 141 times 120 over 360. 47 is 47. And next, no cracks and current technique. Okay. E12. No cracks and current technique. No cracks 141 and current technique 240. This is 141 times 240 over 360, 94. And the next minor cracks and a new technique. Minor cracks is 1, 4, and minor cracks total 150, new technique 240. So E, 2, 1, 50, 120 divided by 360 equal 50. And the next is minor cracks and current technique. It means E to 2, minor and current. Minor, the total is 150, current total 240. And 60, it equal 100. And major crack and new technique. One is, you can see the table, 40, 23. And then major crack and current. And current technique. So E, 32. 69 times 240, 360. It is 46. And then we're going to calculate the chi-square test statistic. The chi-square test statistic okay. The formula is sigma or I minus EIJ squared ah, EIG. Okay. Next, for no cracks and new technique, that is 53 minus 47 over 47. You can see the table. Okay. After that, uh, for no cracks and current technique. That is 88 minus 94 squared. This is squared actually. Divided by 94 is 0.383. Then minor cracks and new technique. Fifty-four minus 50 squared over 50. And this is the result is 0.32. Yes, I'm going to use this space. Okay, next. For minor cracks and current technique, 96 minus 100 squared divided by 100 is 0.16. And then major for major cracks and new technique is 13 minus 23 squared over 23, 4.348 for major cracks and current technique. That is 56 minus 46 squared over 46, 2.174. So the chi-square total 0.766 plus 0.383 plus 0.32 plus 0.16 plus 4.348 plus 221.74, 8.151. And degrees of freedom is R minus 1 times C minus 1. R is three types of cracks, and C are the populations of uh, technique. Yeah. Production of technique. There are two production of technique, new technique and the current technique. Okay. And then R is the three types of cracks. No cracks, minor cracks, and major cracks. 3 minus 1, 2 minus 1. So df is to the degrees of freedom. And p-value, based on this information, this one and this one, p-values, you can determine through table or your calculator is 0.017. Okay. So we can state that at the 5%, yeah, at the 5%, so alpha is 5% or 0.05. Okay. At the 5% significance level, we compare the p-value to alpha. Yeah. When the p-value when the p-value 0.017 is less than 0.05 or less than 5%, it means we reject the null hypothesis. So when p-values uh, less than alpha, okay, so the decisions is reject the null hypothesis. But the conclusion that there is sufficient evidence to reject the null hypothesis. Therefore, uh, therefore, we conclude. I need more space. Therefore, we conclude that the type. Uh, we conclude that the type of cracks is independent of the production technique technique used. Okay, that's the conclusion. The conclusion. Next question. Part D. For the components in the trial that were made with the current technique, show that the proportion which developed cracks is 19/30. So we are going to prove uh, that statement. Part D. Minor cracks plus major cracks equal 96 plus 56 according to the information, and the result is 152. And the proportion of cracks equal component with cracks divided by total component. Total component of current technique. And it is 152 over 240. And simplify becomes 19 over 30. So proof that the result is 19 over 30. Part E. Okay, so as an alternative measure, the researchers decided to let P be the probability that a component made with the new technique develop cracks. They then test the following hypothesis. Null hypothesis P equal 19/30 and the alternative hypothesis P or probability less than 19/30. In a randomly selected sample of 130 components made with the new techniques, let X be the number which develop cracks. The researchers assume that under the null hypothesis, X is with binomial distribution 120 and 19/30. State one additional assumption that the researchers are making in choosing this distribution. E. So I'm going to writing my opinion about this question. The researchers are using a binomial distribution. Okay, I'm going to writing first. Model the number of components that develop cracks. Denote by X, where X binomial distribution 120 and 19 over 30. Okay. In addition, to assuming that that under under the null hypothesis, okay, uh, under the null hypothesis, the probability value equal 19 over 30. So the researchers, sorry, so the researchers are implicitly, I have provided my opinion about this, so going to I'm going to copy my opinion, making the assumption that the trials of each component are independent. So on. Next question is F. Use appropriate data from the trial to perform the test proposed by the researchers at the 5% significance level. State the conclusion of the test, justifying your answer. Part F. Right. F. First, we are going to the first step. Define the hypothesis. Null hypothesis is P equal 19 over 30. And the alternative hypothesis is P less than 19 over 30. And the second step, we are going to determine the total number of components that develop cracks in the new technique, and that is X equal 54 plus 13 equals 60. And as well, assume that the probability of a component developing cracks is probability equal 19 over 30. That's one. And then we're going to calculate the probability. Calculate the probability based on the probability based on the binomial distribution of 120, 19 over 30. So we can calculate that the probability x less than or equal to 67 is equal on your calculator or table. You can determine this 0.0549, okay, for decimal places. And this number greater than 0.05. You know that alpha is 0.051. So decision, the third step, the decision is we are going to, when we are going, or if probability x is greater than alpha, it means we fail, okay, we fail to reject null hypothesis. And the fourth step, the conclusion, the conclusion, we do not have sufficient we don't have sufficient evidence uh, to reject null hypothesis at alpha equal 5%. So this means we cannot conclude that the proportion of components made with the new technique that develop cracks is less than 19 over 30. Next question, part G. In comparison with the test in part C, state one mathematical reason why the test in part F might be preferred. the test in part F might not be preferred. So I have uh, to writing again my opinion. I have to copy from my book part H part one. The test for a proportion is directional and so considers whether the new treatment reduce the number of component the number of component developing cracks. Actually, uh, I have uh, I have more explanation, more opinion about this, but I just copy this information, this opinion. And the second, and not preferred, because there could be variation in the value of probability of P. Okay, it's just chosen for the null hypothesis. Next question. Oh, just now is G. It means next H. For these components, the researchers also consider the mean time taken until cracks develop. It is hoped that using the new technique will increase this value. A second trial is carried out and the times in hours taken for cracks to appear is recorded. The mean time taken for cracks to appear, T bar, and the value of S n minus 1 for each technique are given in the following table. It's a table H. Perform an appropriate test at the 5% significance level to determine whether the new technique increase the mean time taken for cracks to appear. We are going to solving part H. The part H. Just no part G actually. Oh, this one. This is not H, but this is G. Okay. Next H. The first step. The first step is state the hypothesis. That null hypothesis is mu. Mu equal the mu current. Okay, mu is represent the mean length of the time before cracks appear with the new technique, and mu current meaning uh, length with current technique and alternative. hypothesis mu new greater than mu current. Or you can state like this. Null hypothesis is mu1 equal mu2, and alternative hypothesis is mu1 greater than mu2. Mu1 represents the mean length or the time before cracks appear with the new technique, while mu2 is represent the mean length with current technique. Up to you, you can use which one. And the second step, define the given data for the new technique or the new technique. The sample size for N1 is 100, and the mean time T1 minus 1 is 250.1 hours, and the sample of standard deviation S1 is 3.8 hours. This data you can see this table according to this table. The table just now uh is this one. Okay, so the new technique N1 is 100. This is the mean time T1, and this is the standard deviations S1, 3.8 hours. And it means for the current technique, N2 is 200, and then T2 is 249.1, and then the standard deviation is 3.8. So for the current technique, N2 is 200, and T2 249.1 hours, and standard deviation 2 is 3.8 hours. And then the next step is I'm going to add assumption. Third, assumptions is the two sample because we are going to writing our conclusion based in these assumptions. The two samples means are approximately normally distributed, and the sample standard deviation, the sample of standard deviations are known to be equal. And the next step is the fourth step. I'm writing here. The fourth step is test statistic. Firstly, standard deviation. variance, and 1 minus 1 is 1 squared minus 2 variance 2 over n1 plus n2. So 1 is current, 1 is new, and 2 is current, minus 2. 100 minus 1 is 99, and this is 3.8 squared. This is 199 because 200 minus 1 divided 100 plus 200 minus 2. It means 298. And if you calculate the result, it's 14.44. And the next is T. T equal T1 minus T2. This is new and this is current. New cracks and the current new technique and current technique. Variance 1 over n1 plus 1 over n2. 250.1, 249.1, 14.44. Sorry, 1 over, I mean, 100 plus 1 over 200. And if you calculate, the result is 2.1486. Round off becomes 2.149 actually. Well, okay, 87 because this is 69 here. Okay, 67. Okay, this is 67 actually here. Okay, and after that, degrees of freedom. The degrees of freedom is n1 plus n2 minus 2. That is 298. And the next step, the fifth step, find the p value. Okay. So when t equal 2.149, you can round off becomes 2.149. With df 298. Okay. And alpha 5%. So the p value equals 0.0162328. Yeah. And the sixth step conclusion, that p value less than alpha, less than 0.05. This one. Okay. 0.01 is 0.05. So it means so we are going to reject the null hypothesis. So we can state that the three sorry, that uh, sufficient that is the sufficient evidence at alpha equal 5% to conclude okay, that the new the new technique increases increase the mean time taken for cracks to appear. One. And next. The company decided to go ahead with a new technique and publish the following statement. Statistical tests showed the new technique will significantly increase the time before components crack and need to be replaced. Comment on this statement. I have provided my explanation about this, my opinion about this, and I will copy my. I'm going to writing my opinion about this question. Part I. This statement implies that that the new technique will cause a significant increase increase in the time before cracks appear, but in reality this increase is so small that it might not justify the cost of effort required to adopt the new technique. That one. Number two, a sports stadium has a dessert cannon, which is used to launch dessert into the crowd. The purpose of this question is to determine whether a person sitting in a particular seat will ever receive a T-shirt. A T-shirt cannon is placed on the horizontal ground of a stadium playing area. A coordinate system is created such that the origin O is the point on the ground from where the t-shirts are launched. In this coordinate system, X and Y represent the horizontal and vertical displacement from O and are measured in meters. Seat A1 is the nearest seat to the t-shirt cannon. The coordinates of the front of the foot space for seat A1 are 30,2.1. That is the diagram. Next. Each seat behind seat A1 is 1.0 meters further from O horizontally and 0.5 meters higher than the seat in the row below, as shown on this diagram. Seat A1 is in row 1. Let seat AN be the seat directly behind A1 in row N. Write down the coordinates of the front of the foot space of seat A5. A part 1. Horizontal displacement given horizontal displacement given 30 plus 4 multiply 1.0. Okay, if you look the diagram, 1, 1, 2, 3, 4 at the row 4. Okay. So this the first step is 30. And the vertical is 2.1 and times 4 multiply 1.4 and it is 34 meters. While the vertically displacement 2.1 multiply 4 2.1 plus 4 multiply 0.5 and it is 4.1 meters. So the front of the foot so just foot space of seat A5 at A5 the coordinate is 34, 4.1. That one. And part 2. Sorry, part two. Fine. In terms of n, the coordinates for the front of the foot space of seat AN. Part two. For horizontal displacement, it is the x coordinates. It is xn equal 30 plus n minus 1 multiply 1.0. You can evaluate the diagram. It becomes 30 plus 1.0 n minus 1.0. It is 29 plus n. And sorry, the vertical displacement y coordinate yn equal 2.1 plus n minus 1 multiply 0.5. 0.1 plus 0.5 n minus 0.5. It is 1.6 plus 0.5 n. So the coordinate will be 29 plus n, comma 1.6 plus 0.5 n. 1. Question B. This one. While in motion, the t-shirt can be treated as a projectile. Let t be the time in seconds after a t-shirt is launched. At any time t greater than 0, the accelerations of the t-shirt in meter per second squared is given by the vector. This is the vector. This is acceleration, x acceleration and y acceleration. The initial velocity in meter per second of the t-shirt is given as this matrix, where theta is the angle to the ground at which t-shirt is launched and theta interval 0 to 90. Find an expressions for the velocity xy at time t, hence show that when the shirt is launched vertically, the time for it to reach its maximum height is 3 seconds. B part 1. Acceleration, the acceleration vector for the shirt is A is 0 and minus 9.8 meter per second squared. And the the initial factor of the surd is this one, V0, 29.4 cosine theta and 29.4 sine theta. And velocity, the velocity Vt, this vector is equal V0 plus AT, A times T, becomes V0 is 1, 29.4 cosine theta and 29.4 sine theta plus A, this one, 0 minus 9.8 times T. So it becomes 29.4 cosine theta plus 0 times T plus 0. And this one, 29.4 sine theta plus T. This one. Sorry, not minus, sorry, minus 9.8 T. Sorry. 9.8 T, that one. So the velocity factor at any time T is this one, Vt 29.4 cosine theta, 29.4 sine theta minus 9.8 T, the one. Part 2. When the third when the third factor this one at time t, factor this is comes vertically. It means theta would be 90 degrees if vertically. So we can state that V0, the initial factor, will be 29.4 cosine 90 because theta equal 90 and it is 29.4 sine 90. Okay. Cosine 90 is 0, so it is 0, and cosine and sine 90 is 1, so it is 29.4. So the initial velocity the initial vertical velocity, it is 29.4 meter per second. This is vertically velocity. Yeah. And the velocity at time t when launched vertically, it becomes like this. Vt is 0, 29.4 minus 9.8 t. If this is if this is 90 and this is 90, so Vt becomes like this. Yeah. Okay, next. At maximum height, the vertical velocity will become 0. The vertical velocity becomes 0 at maximum height. At maximum height. So we are going to set the vertical component of the velocity becomes 0. So it means 29.4 minus 9.8 t equals 0. Becomes 9.8 t equal to 29.4. So t equal 29.4 divided by 9.8, and it is 3 seconds. One. So the time for the shirt to reach its maximum height when launched vertically is this one, 3 seconds. Next question, C. The displacement of the shirt 30 seconds after it is launched is given by the vector equation. Using the given answer to part B, part 2, or otherwise, find the maximum height reached by a t-shirt when it is launched vertically. Part C. The displacement of the t-shirt is given as this one. This is the displacement vector 29.4 cosine theta t times t, and this is 29.4 sine theta times t multiply 4.9 t squared times t. And for the vertical motion, theta equal 90 degrees for the vertically motion. So it means cosine 90 equals 0 and sine 90 equal 1. So this vector becomes, this is 0, it is 0, and this is 1. 29.4 29.4 times t, okay, times t minus 4.9 t squared. Or we can write it like this. T here, or t multiply 29.4 like this. And this is the vertical displacement. The vertically displacement, we can state by yt equal 29.4 t, this one, minus 4.9 t squared. For the maximum heights, we are going to substitute 3 seconds, 3 seconds into this equation. So y3, it is 29.4 multiplied by 3, 4.9 multiplied by 9, because 3 squared. And if you calculate, the result is 44.1 meters. Next question, part D. 1. If there was no seating and the dessert was launched at an angle theta, show that the value of x when it would hit the ground is given by the expression x equal 176.4 sine theta cosine theta. And 2, hence find the maximum possible value for x if there was no seating to block the path of the dessert. In part C, we have found the vector 1 of displacement 29.4 cosine theta times t and 29.4 sine theta times t minus 4.9 t squared 1. So it is function x, xt is 29.4 cosine theta times t, and yt is 29.4 sine theta times t minus 4.9 t squared. When the stilt hit the ground, it means yt equals 0. So this equation becomes 29.4 sine theta times t minus 4.9 t squared equals 0. Factorize t, 29.4 sine theta minus 4.9 times t equals 0. So 20 divided by t becomes 29.4 sine theta minus 4.9 t equals 0, or 4.9 t equal 29.4 sine theta. So t equals 29.4 sine theta over 4.9. 29.4 divided by 4.9 is 6. So 6 sine theta. Next, substitute. The next step is substitute. Substitute t. The substitute t into equation for the horizontally displacement, to horizon, the equation for the horizontally displacement, and xt. So xt is 29.4 cosine theta times t. Okay. Wait, I'm going to writing it. So this is the vertically displacement. This one. And this one, and xt is horizontally displacement equation. So it becomes x 6 sine theta equals 29.4 cosine theta multiply 6 sine theta. 29.4 multiply by 6 is 176.4 sine theta cosine theta. So the horizontal distance x when the surge hits the ground is given by this expression. 176.4 sine theta cosine theta as the request. According to the trigonometric identity, that sine 2 theta equal to sine theta cosine theta, or 1/2 sine 2 theta equals sine theta cosine theta. So let's look this result. If x equal 176.4 sine theta cosine theta, it becomes sine theta cosine theta is this one, 1/2 sine 2 theta, 4 multiply 1/2 sine 2 theta. And it becomes 88.2 sine 2 theta. The function sine 2 theta, I'm going to write in here the function or the expression sine 2 theta has maximum value has maximum value the maximum value if trigonometric maximum value is 1 when 2 theta equal 90. So sine theta maximum value is 1. So it is, yeah, and it occurs on 90 degrees. It means sine 2 theta will be maximum at 90. If I will write in here, if sine 2 theta equal 1, it means sine 2 theta cosine 90 and 2 theta equal 90. That one, 90 degrees, I mean. It means theta equal 45 degrees. So maximum value of x occurs when theta equals 45. This maximum value occurs. Okay. And the maximum value of x and the maximum value of x, I need more space, maximum value of x, or x maximum, it is 88.2 multiplied by 1, 88.2 meters. So the maximum possible value for x, the horizontal distance that the circuit can travel is 88.2 meters. When the transist is launched at angle, it's 145 degrees. Next question, what's E? Using your answer, oh, sorry, I have to, this one, okay, for this one. In order to calculate the seats in the stadium, which can be reached by a T-shirt, it is required to find the equations of the curve that forms the boundary of all the points that can be reached. This boundary is represented by the dashed curve in the following diagram. This curve I'm going to show you later. While the solid curves represent some of the possible trajectories for the shirt. This is the diagram. It is given that the boundary curve is the parabola with equation y equal ax squared plus bx plus c with its vertex phi on the y-axis. Okay, vertex phi on the y. This is the vertex phi on y-axis. Using your answer to part C and the part 2 or otherwise, find the value of C, the value of B, and the value of A. Part E. In projectile motion, if you look at the previous diagram, the maximum height occurs, better if I write the maximum height, it occurs, sorry, it occurs when the vertically velocity equals 0. So it means y equal ax squared plus bx plus c. This is the velocity. We can writing that y equal a times 0 squared plus this is 0 times b plus c. So the implication y equals c. From part C, if you evaluate part C, that's given the high maximum, part C, the high maximum, okay, it is 44.1 meters. This is the high maximum on part C. So we can state that, this is y, okay, y, high maximum is y. So we're going to say that C equal 44.1. Yeah, this is part 1. Part 2. Y equal ax squared plus bx plus c. To get the maximum value, we are going to find the derivative. So derivative of this function, dy dx, dy dx equal 2ax plus b. Okay. And it should be 0. So after that, we can say like this, 2ax minus b. So x minus b over 2a, like this. So the vertex at x-axis, the vertex at x-axis is equal 0. Okay? So it means minus b over 2a equal 0 as well. And then we can state that b equal 0, this one. Part 3. Maximum horizontal distance dy dx according to part 2, it equals 0, or 2ax plus b equals 0. According to part D, I'm going to writing here, part D, that the x maximum is equal 88.2. You can evaluate uh, part D, and C, according to the part C, it is 44.1. Well, now, but we are going to using this one, 88.2 as well. And for the x maximum, so x maximum occurs when y equals 0. When y equals 0, we can get the value of x maximum. So the coordinate point, uh, the coordinate point would be this x 88.2, 0. This x, this is y. And from part 2, we got b equals 0. And part 1, we got that c equal 44.1. Now substitute this information into this equation, ix squared bx plus c. Y equals 0, and a, after that, x is 188.2 squared, plus b is 0, and x is 188.2 plus c 44.1. So it becomes a 88.2 squared plus 0 plus 44.1 equals 0, or a 88.2 squared minus 44.1. A equal minus 44.1 over 88.2 squared. Okay. That's 1A. So we can state that y, so y equal minus 44.1 over 88.2 squared. You may simplify this one, okay, but I will not simplify. X squared plus 44.1. This is y. Next question. F. A spectator is sitting in seat A40. Show that it is not possible for the spectator to ever get a t-shirt. A40. That's F. I'm going to writing here F n equal 40 because A40. So an it means n equal 40. According to part A2, that the horizontally displacement on part part A2, we can evaluate uh, that horizontally displacement is uh, this is an equals 29 plus n. Okay, so it means if A40, it is 29 plus 40. It is 69. Okay, next. On part A2 as well, for the vertically displacement, A40, according to part A2, that an as well, 1.6 plus 2.5 n. Okay, so A40 it means 1.6 plus 2.5 times 40, and the result is 21.6. So the coordinate point of seat can we can state that 69, 21.6 x, y, horizontally, vertically. Next, substitute x equal 69 because we are going to find the distance horizontally, okay, into y equal minus 44.1 over 88.2 squared x squared, sorry, of x squared 44.1. It is minus 44.1 over 88.2 squared. X is 69 squared plus 44.1. And the result is 17.1102. Round off becomes 17.1. Okay. Now evaluate for the previous result that the maximum height of A40 is the 21, the vertical displacement 21.6. So it means we can, I'm going to writing here that 21.6. This is the maximum height of the maximum height, this one of A40. So 21.6 is higher, or I'm going to using better writing here, is higher than this meters, okay, higher than 17.1 meters, or 21.6 greater than 17.1. So we can state that the the shirt cannot reach seat A40. This is the conclusion.